Okay, so welcome to this set of slides on binary and hexadecimal. So if you already understand how binary and hexadecimal work together, then do not watch this video. Then you won't learn anything new. Okay, but this is for build up to the IEEE slides. So if this is something that you need some refresher on, or if you never learned it in the past, then this is why you'd learn these slides. Watch these slides. Okay, so binary numbers. Computers can only understand on and off. All numbers are stored as zeros and ones. So it's logic high and logic low. It's not literally 0 and 1. But in the model we use to understand the world, they're 0 and 1. As a programmer, you need to know binary. You'll need it for, if you're programming the web, you'll need to know colors and file permissions. Ignore this line that says we will design our web design. That was for my computer science class, not for my numerical computing students. Okay? All right. Humans use base 10. This is what you've used since you were a child. And so you probably saw charts like this in grade school where you put the 3 in the ones column and the 2 in the tens column and the 7 in the hundreds column, and then that means the number 43,723 because each digit actually represents a bundle, and you might have bundles of sticks in your diagram or whatever. Okay, so this you should understand. You could use 5. You could use any number you like, but here's just an example of 5. So what if I had the number in base 10, which is 43423 base 5, turns out to be equal to 2988 base 10. And the way we know this is we say, hey, split up the digits into their bins, just like you did with base 10, but now the headers are different. It's 1, 5, 5 squared, 5 cubed, and 5 to the 4th. Add all that stuff up together, and it tells you what the actual number is in the number system we know and love, which is 2,988, but it's represented as 43423 base 5. We do say it that way. We say 43423 base 5. You do not rephrase it. Don't say like 10 base 5. Like, don't say that because it's just confusing. Here's what it looks like in base 8. So then you have the headers 1, 8, 8 squared, 8 cubed, 8 to the 4th. And let's try the number 73123. And notice we only use digits up to, but not including the base system. So you can use digits up to 7 in base 8. We use digits up to 9 in base 10, right? Okay, so we dump the digits into the template, and then we say 73123 base 8 is 7 times 8 to the 4th plus 3 times 8 cubed, and so on and so forth. Okay, so we would say 73123 base 8. Computers use 2, 8, and 16. Most commonly, at least in numerical computing, we're only going to use 2 and 16. So we can kind of forget the 8, but it's good conceptually to sort of build us up there. Okay, so what you would like to do is try converting this base 2 number to base 10. You should pause the video and come back and see if you got it right. Okay, hopefully you're back now and you have added everything together. You found that 64 plus 32 plus 8 plus 2 is 106, base 10. Let's try going the other way. So to go the other way, you find the sequence of ones and zeros that does this. So you would look and say, first of all, you don't need a 128, but you do need a 64. So then you're going to do a subtraction, and you're going to spread this out. Every box either gets a 0 or a 1. So go ahead and try that. Hopefully you found that you started with taking away 64 and you got 33, and that means you need a 32 and a 1. Don't worry about getting to the right answer by cheating in this case, because there's only one exact right answer. Like if you realize, oh wait, it's an odd number, I better use the 1, all the other numbers are even. Well, that's fine. That's perfectly logical. It doesn't matter if you do them out of sequence as long as you get the right answer. Okay. So as a courtesy, we group these in groups of 4 digits as opposed to in base 10 where we group groups of 3 digits. So we group groups of 4 digits, and this allows us to convert to hexadecimal very easily. First, let's try converting 99 to base 2. And also try convert, so there's one of each. So there's a binary number to convert to base 10, and then convert base 99 base 10, convert it to base 2. Try those. So pause the video, do those 2 exercises, and then come back. Okay, so the first one should be pretty easy. You just add up all the ones. The one is telling you to add a 28, a 32, a 16, and a 4, and that gives you 180. And then there's converting 99 to base 10. So you do the same sort of backwards subtraction. You don't need a 128. You do need a 64, so you have 35 remaining. Subtract 32 to get 3, subtract 2 to get 1. So you just apportion all that, and then that's what your answer would look like. Okay, base 8 works the same way, and if you have 4096 plus 3 copies of 512 plus 7 copies of 8 plus 4 ones, then you'll end up with presumably 5692 base 10. Okay, so here's a fun trick. If you want to convert from base 8 to base 2, and you're going to need to know this for hex, this works the same way in base 8. The relationship between base 8 and base 2 is almost identical to the relationship between hex and base 2. Okay, so if you want to convert base 8 to base 2, you don't convert by going to base 10 and then going to base 2, because that's a huge amount of work. You do the short and easy thing. You say, hold on a second, I'm going to look at all the 3-digit combinations of zeros and ones, so 3-bit integers in binary, okay, and I'm going to convert them one at a time. So in the 64 place, I have a 0, so I just rewrote this here for fun. Okay, so 0 is 0, 0, 0, whereas 7 is 1, 1, 1. So you basically take a binary, you translate each of these individual digits into binary in a 3-digit fashion, and you prepend any zeros as necessary, and then you just glom them all together or glue them all together, but then you just break them up in groups of 4 instead of groups of 3 because we really actually prefer hex, and that helps us convert to hex better later. But that's how you would write that base 2 number. Okay, this trick only works because 2 times 2 times 2 is 8. It doesn't work in most situations, but for example, it would work between, say, base 3 and base 27. That would work. Or base 5 and base 25. That would be fine. Okay, as long as you're raising a base to a power to get your new base, then it will work. Okay, so here's some practice problems. You can pause the video and get those answers. And here are the answers, and I put little dashes down here so that you know you have to like regroup everything. This works in base 16, but wait, this is crazy. We only have the digits 0 through 9, right? No. We also have A, B, C, D, E, F in base 16, and you've probably heard this before. Even if you're not fully aware, it's going to start clicking now. Okay, so A is 10, B is 11, C is 12, D is 13. And so when we want to convert from base 16, we simply just take and do the same process, but if we see the letter A, we put in a 10, B, we put in 11, and so forth. F is 15. And then the process works just fine. Just fun little things to try. If you have the number in base 10, 99999, and you add 1, what happens? Well, everything rolls over. So the same thing happens in base 16. If you have F, 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 and you add 1, all the F's turn into zeros and you prepend a 1. It's just like adding a 1 to a string of 9s. We often do not denote hex values if it is obvious that there are letters, so but people understand that that's hex. Hex is also another word for base 16, in case you didn't catch that. Base 16 is the same as hex, which is the same as hexadecimal. Oct is the same as octal, which is the same as base 8. So these are just different ways of expressing the same thing. Okay, so in Python, we can do this. So I'm just going to show you this real quick. In Python, we can just convert these and do these exercises. There's also online tools you can use, but you may as well use Python since you've got it. So I would just say 10, 10, whatever, base 2, and it tells you. But you could also do things like this. Good. I like to write words in base 16. So I'm using the number 6 to mean a G. Good is 2, 4, 5, 8, 9. Okay, so that's just kind of silly. Okay, I just asked for full screen again. There you go. It's not happening. There we are. Okay. If you want to convert into binary or into hex from base 10, that's not a problem. You can convert into binary, into decimal, into octal, or into hex. Python doesn't make other permutations easy, but for the common ones that we use all the time, it's really easy. Use the word format, and you put the base 10 number in first, and then the second argument is that single character which tells you what your output type should be. Okay? It would be useless to use D because you're going from decimal to decimal, but you know, whatever. Like, it would make sense in the context of a program. Those functions will permit you to check. Again, this is a comment from my computer science student, so don't worry about the computer science homework. This is above and beyond what you need for the NumComp homework. Okay. Okay, here's just a little chart that shows you the hex digits with the base 2. Since this is a video, I don't have to spend long on this. You can pause the video anytime and focus on a slide. So I'm just going to go right on and say, what if I want to convert face, bad, cabbie, and boss? I'm just being silly. So I'm going to take some things that look like words, but they're really base 16 numbers, and I'm going to convert them. And I'm just going to use the table and convert over directly. Okay, so face is F-A-C-E, F is 1111, A is 1010, C is 1100, and so on and so forth. And go ahead and figure out what this dorky thing says, the dorky words that I've made up. So you can pause the video and convert those. Babe, cool, fads, and bags. Again, they're just made up words. They're not really words, they're numbers, but just to be silly, I make them spell words. Okay, and that should be enough. Hopefully then you understand how to convert between binary and hex and octal also. And then you should be all set for what you need to do for the IEEE lesson. So that should be all set now.